Hello and welcome to the presentation of Group 5. The Human Activity Recognition Project was done by Kevin Asokba, Manika Kanjale, Ashwini Jaitapkar, Asim Mehta and myself Deepam Shah. So the heterogeneous data set for human activity recognition from smartphone and smartwatch sensors consists of two data sets which are devised to investigate sensor heterogeneity impacts on human activity recognition. The dataset contains the reading of two motion sensors which are commonly found in smartphones. The readings were recorded while users executed different human activities like walking, biking, walking upstairs, walking downstairs, and sitting or standing. In our dataset, we have four smartwatches, eight smartphones, and there are total 9 users. So we have done the data mining with R, and we have pre-processed the data, we have visualized the data, and we have also normalized the data.
Coming up to the data description part, the data has been taken from UCI machine learning repository. The data was collected using two sensors, accelerometer and gyroscope on smartphones and smartwatch, and was split into four files: watch accelerometer, phone accelerometer, watch gyroscope, and phone gyroscope. Namely, the data set contained around 30 million entries which were split into these four files. Each table consisted of 10 attributes. Index, which is the index of each record. Creation time is the timestamp given by the OS. XYZ are the user speed and acceleration axis measured in three different axial directions. User is the identifier. Model is the device model. It can be like Gear, LG Watch, etc. Device is used to keep a track of device which was given to a user. The devices were 4 smartphone watches and 8 smartphones. The last column is the ground truth. It contains the human activity that the person was performing while the data was being recorded.
In data pre-processing part, majorly we have taken care of handling null values and done normalization. Coming to handling null values, the attributes that were considered were X, Y, Z, and the ground truth attribute. Decision tree was generated with the data set having null values and without having null values. And finally, we discovered that there was an equal level of accuracy between both the data set. So null value wasn't removed at the end. Coming to normalization, X, Y, Z axis data and creation time, arrival time data was been considered, and mean max normalization was been used to reduce all the numerical data to range from 0 to 1.
As integral part of the decision tree model building, we proceeded to the engineering of features in order to increase the size of our feature selection set. And those features are used to train the model. So for this data set, we've included two new features, one which is the process time obtained by finding the difference between the arrival time and the creation time, and the Euclidean distance between the sensors and the reference coordinates, which is 0, 0, 0. This could help us to modulate the movement of the user while recording those values. So the data split comes, and we've split the data into training and testing model. We've tried different combinations, different ratios of 50-50, 60-40, and 70-30 as experiment in order to select the best parameter. And out of those computation, we've decided to move forward with 70-30 as split ratio because it gained the best result among all those options.
Let me quickly take you through our project code. Out of all our four databases, we have using watch accelerometer. Here we are going to predict the value of column GT. Let us look at the code. This part of the code is used to normalize the data between values 0 and 1 for all the numerical values. And this part is used to append those values back into the dataset. We're using a split ratio of 70-30 for our dataset for training and testing. This part of our code is used to find a feature Euclidean distance. In this feature, we find the distance between x, y, z coordinates and our standard reference point 0, 0, 0. And we append back this Euclidean distance into training and testing dataset. I have already created a tree model. As you can see in our model, Z and arrival time values occur the most. The prediction, this part of the code predicts our accuracy, and we have received an accuracy of 55%. Now let us talk about results. On all our 4 datasets, we have received an average accuracy of 56%. We have also made multiple observations during this project. We have found that a given variable is not assured to appear for classification. We have also seen that a model may overfit, and due to this overfitting, it may result in unreasonable accuracy. We have seen between gyroscope and accelerometer sensors, gyroscope provides a higher accuracy. We have also observed X, Z, and arrival time give a better accuracy or play a major role in accelerometer based models, while process time plays a major role in gyroscope based models. This has been our project. Thank you for listening.